Right, let me show you what I've been doing since my last video. Well, I've progressed a bit. Now, let me turn it around a bit here, all the various, then I'll strip it down so you can see on the inside better. As you can see, I fitted the USB port there, wired up and so forth. Now, I've got a switch as well. Let me show the voltage this stepper motor, little one, produces. Okay, this is the negative side, and this is the positive here. Now here's the, I hope you can see it, the meter. Let me see. I don't know whether you can see or not. The light. Okay, that's better. Okay, let me hold it a bit. As you can see, it's maybe the other way around. Let's see. Is it better this way or no? No. Anyway, open circuit, it produces something like 16 volts. And the switch here is at the center. This is a two-way switch with the center being neutral. So on the neutral position, one can either, well, fit an outside appliances here through the port and charge it. On the other hand, you can use it sort of for the light side of it. Here where the crocodile clips are, here will be fitted the, well, will be fitting a swivel voltage meter. The same thing applies for the light. Well, so similar to this one which you seen it previously. Well, there are a lot of differences though to that one. Now let me strip it out a minute so you can see the inside of it. Get a better view how to get the current flowing all about at the top without sort of wires. I suppose one can do a better job than I have, but it's always the first time. I'm sure someone out there will do better than me. Okay, we take the handle off here first. These two. Everything is sort of temporary to keep those plates in place where the current flows. Right. There we go. Yep. These are the spaces I was talking about. This is fiberglass tubing, which I found, but I suppose one can fit anything. Up here you don't need it because here we will have the voltmeter swiveling, so we'll have the light on that side, so that the space will space itself. But this one you can do in aluminium, anything that can give the same distance. The distance here, this one is 33 millimeters, and obviously the items which will be fitted at the top will be the same distance. Okay, there we go. Out she comes. So you can see what I. Okay, let's get this out. Okay, here you can see, I hope, Okay, these are the plates I was talking to you about, how to transfer the power up to the top with that sort of wire. So this is a very thin tin plate. Maybe one can use Coca-Cola or some sort of tin which is much thinner, or even a wide plate made to measure, designed, and then sort of cut it through and put a complete unit in it. I suppose it can be done. The size of it is as big as a hard disk anyway. So basically you get a hard disk drive and make it, sort of draw it out, and then fit all these plates here. There you are. Here I fitted the USB port. And yeah, the 4 wires I was talking about last time. You have a red and a white, a green and a black. So just to be on the safe side, because as I say, from my Apple computer and the Acer computer, if I put, let's say, these here, it will light on the Apple, but it won't on the Acer. It all depends on the wire. So to be on the safe side, once you've checked out which are the plus and the minus, the 2 plus, you put it together, solder it together there, which come out from the stepper motor, and the negative one will come out from the negative side of the stepper motor. So whatever appliance you fit here, whether it's the red or the blue or the white or whatever, you know it's going to light up or it's going to charge. So as you can see, it moves. But that one, if you put the other casing here, it will hold it in place nice and tight, like it will hold the capacitor, so it won't move. It's sort of measured correctly. So here we have the light, that is the coming out of the capacitor. But if you put it at the center, or you go up the top, the switch, and you crank it, it will charge the capacitor. At the center, without these, you can put, say, a battery, an external battery, or a phone battery, whatever, and it will charge. As I say, open circuit, it will produce about 15 to 16 volts. But whatever battery you put in there to charge, if it is a 4-volt one, it will charge the 4-volt. If it's a 9-1, it will charge the 9-1. I've tried that. So as I say, it's not that difficult to create. It needs a bit of patience, obviously. Is there anything else I need to add? I don't think so. I suppose at the end of the video, most probably I'll remember something which I haven't said. Oh, by the way, hold on a second, I did say this last time. See, the shaft here, or the gear, has got a recess, a natural one. It was that way because then what I did, I drilled the shaft and put a pin in there, and I sort of slotted in into the gear so that the gear and the shaft sort of is a one unit thing. I didn't make it myself, but obviously if the gear hasn't got that, you can make that yourself by heating it up, the shaft, and pressing it down. It can be done. I've done that. So these are all the various bits and pieces. As I said, this one is almost finished, although I started it last week just to show you the principle of the bigger gear. Instead of having 4 gears like the other one, that gave me space, because the ratio is exactly the same, 14 to 1. 13 to 1, 12 is the ideal ratio for the motor, because if you multiply that, it gives us a steady sort of turning of the crank. This turns about 780 turns per minute. If you go faster, it'll go higher than that. But as I say, it turns at about 780 per minute, which is comfortable to produce enough voltage and current. So, I was going to say something else, and I forgot. So, I told you about that, the capacitor, the USB, you've seen it, and this how, as far as wiring is concerned, I mean, you have to wire it the way you feel it is right for you. I mean, this switch here, as I say, it will light the bulb. Flicking to the other side, you'll have the stepper motor charging this one. Now, my intention is to fit on the empty space here, or on this back plate here, a circuit like a toroid or something, like the other ones, and hopefully it will come out efficient like one of the other three. They're all efficient, but there is this one particular one which I showed. That one is really efficient, and I tried it today again by sort of trying this Chinese capacitor. I charged that one at 3.2, always do anyway, because although the manufacturer says it's 2.7 volt, surely they don't stop there. There must be a maximum that you can actually go without. I think it's 10-15%. And as I say, it works fine without damaging it. And I tried this one on that efficient one, and I think after 2 hours it still produced usable, very good light. I mean, the big bulb I showed you about. And after 3.5 hours, the bulb was still lit. Obviously, it was weak, but it really went up even more than an hour and 20 minutes. And with a few cranks, you can charge the capacitor back again. As I said, I'm going to try to fit a circuit here to try and lit one of those big bulbs. If I want to, I can still use one LED sort of operation. It's a question of varying the wiring diagram here, which one is going to switch off and so forth. There is one over there, one of those other chargers, which the internal battery, as I sort of lit the bulb, it will charge the capacitor as well, and it will never overcharge it. So it's handy as well to have that if you don't want to. Once you have the light on, it will charge the capacitor. It will stay at about 320 or 325. I never go past that, and that's a good thing if you want to do that. But the amazing thing is that circuit is so efficient, which I haven't been able to replicate, although the parts may seem all the same. I think it has to do with the toroid, which I wound it some time ago, but I can't remember the ratio of it, of the joule tip with the secondary side of it. And if we take into account that on the base side, I believe I'll be making a drawing of it. I have a diode going through it. Then I have half a kiloohm of resistor. Did another one in series, and I think there are 3. I think at the end of the day, I worked it out and measured the resistance, and it works out at about 15 kiloohms of resistance, and it produces such a amount of light. Is incredible. I would have thought that I would have to reduce, but I made a bit of trickery with the way I did the wiring, which I'll be sort of making some sort of drawing on it, and hopefully you can replicate it and can achieve that, what I achieved with that circuit. But I've done it with the others, exactly the same parts, the same thing, but I cannot get the same results. So it's got to be the toroid side of it, which give me that very efficient circuit for a capacitor, although it's 400 farads, to last nearly 2 hours. I mean, full blast, and then it sort of slowly fades away. But after 4 hours or so, you have the capacitor. If you put the voltmeter reading, let's say, half a volt, and still you can hear the buzzing of the toroid, so still producing sort of very weak, feeble light. So I believe it must be the toroid side of it. Now, I'll leave it open a few more seconds here so you can see, I hope, here, getting closer to the camera, the way you actually put the plates to take it up the top there. And that is maybe because if you don't have to, the voltmeter which is going to swivel, or the light which all the tools you've got, then obviously all these you don't need. But by doing this way, obviously you forget it. I mean, you put this plate all around it, and they last forever. That's all. Okay, I don't think I have anything else to add. I suppose in my next video, when it's all completely done, I'll just probably remember something else and forget something else. Anyway, thanks for watching. Bye-bye.